Oh, hi. Sorry, was getting asked a question about spiders and completely like blue screened there. Welcome to United Astronomy Clubs of New Jersey. Um, we're here in Jenny Jump State Park in Hope, New Jersey. I want to welcome everyone in. It looks like we have a couple people who might want to have come on in, find a seat, and settle down. So while I'm giving them a chance to do that, I also want to welcome the people online. So hi, because we do live stream these presentations on both Twitch and YouTube. Uh, in addition, I do want to, if you ever have a chance, do check us out on our website, uacnj.org. It's where you're going to find a list of all our upcoming talks. There are 2 left here on site in Jenny Jump State Park for this season, after which we will be going to online only from November through March, and then we'll be back here again in April on site. It's just a little bit too cold and icy during the winter to have the presentations here, so we do switch to an online only format at that point. We also have a list of all our member clubs because we are actually a club made up of other clubs. And one of the easiest ways to get into astronomy, if you're looking at getting your own telescope, is to join your member club, get a chance to look through all of everyone else's telescopes first, find out what the ins and outs before you decide what telescope you might want. In addition, you can check us out on our social media pages, our Facebook, Instagram. We have a Discord server, all great places to share your astronomy photos as well as ask any questions you might have. I do check those regularly. And if you happen to be viewing this online, or if you go to our past broadcast, because we do keep all of these presentations saved on YouTube, and you're like, man, I wish I could ask this question, do drop those questions in the comments. And like I said, I do scroll through fairly regularly to be able to get those answered for you. Now, since it looks like I think most of us are filed in, I think, for tonight, for you, those of you who are here, if you need to use the restroom, that would be the porta potty outside. It's blue. It is illuminated by red. You might have seen it as you were walking down here from where you were parked. When we go to leave, we are using our headlights because we are not a fan of getting run over or seeing other people get run over, and would like to keep our record of 0 people getting run over at 0. So much appreciation with your help with that goal. If we're walking around, it is quite dark because it is very overcast. So any flashlights we might be using, I do ask that you keep those pointed towards the ground because we don't need to accidentally blind people. Normally after the presentation, it's when we would have stargazing, but as you might have noticed on your foggy trip up here, we are currently in the Cloud Nebula, and no astronomy targets can be sighted. I don't know whether we will have a observatory open so you can at least look at a scope. I will see if we have anyone available to do that. We might not tonight because what scopes we normally have open are actually dependent on what volunteers we have that night. That being said, you're not here to listen to me blabber on for forever. You're here to listen to Walt. Walt Windish has been interested in astronomy since he saw the Pleiades at a Boy Scout. He bought his first telescope in 1985, just in time to see Halley's Comet. Walt is a member of North Jersey Astronomical Group and the Rockland Astronomy Club, and he's been volunteering here at Jenny Jump for over 20 years. And with that, here's Walt to tell us about all the scary things in space.
Thanks, Kim. And thank you all for coming out in this weather. Wow. It's I didn't think I'd have half as many people, so thank you so much. How many are camping? Nice. We got some real campers. Very nice. And welcome to everyone online. So we get close to Halloween. and I can't help myself by putting together a scary slideshow. And the Earth seems to be the safest place on Earth, in the universe, but sometimes it's not so safe either, is it? But Halloween or not, the universe can be a scary place. And I've just picked some random slides that I thought were a little scary, and they fall into three categories. There's objects that don't look scary, but are scary because of their power. There's objects that look scary and are scary, and there's objects that look scary but are not scary. And I'll leave it to you to decide which is which. I'll give you a little help though. But don't worry, I'm not one of those clickbait YouTubers. You got to listen to me now because the world's going to end tomorrow and all. No, I'm just here to have a little fun. I hope we learn something. And besides, on astronomical scale, most of the events I'm talking about will take millions or billions of years to happen, except for the occasional asteroid smacking into the Earth. But other than that, we're pretty good. The image behind me is a great place to start. It's one of those that looks scary but isn't scary. It's called the Ghost Nebula and Goblins. And really, it's the astronomical equivalent of looking up at the sky and seeing clouds that remind you of certain shapes. These are just dust clouds, gas clouds, and they happen to have some pretty cool looking shapes to them. This one is a reflection nebula. That means the glow is coming from light being reflected. The other type of nebula is an emission nebula, where there's hydrogen atoms that are being excited by a star, and so they're actually glowing. This is just being backlit, just like the screen. This is in the constellation Cephus. It's about 1,500 light years away. And when you think of it, when I say 1,500 light years away, that means it took the light from this object 1,500 years to get here. So we're not seeing this object the way it looks today. We're looking at this object the way it looked 1,500 years ago. And so in a way, telescopes are like time machines, because the further away you look, the further back in time you look. That's why scientists are so interested in seeing. We can see almost to what we think is the beginning of the universe. We're 13.8 billion years for the universe, and they can see within about 500 million years of that. And so when they see old galaxies, they're looking at galaxies that are close, just hundreds of millions of years from the beginning of the universe. And so they study galactic structure. And the James Webb Space Telescope, I did a talk on this a couple months ago, has given us some real surprises, because they found stuff that's a lot more developed than their theories thought. So every time we put a more powerful scientific instrument that can take deeper pictures and measure more clearly, we always have our theories tested. Sometimes they hold, sometimes they don't. So that's always a lot of fun. That's the scientific method. Trust the science means trust scientists to keep reviewing their hypotheses and testing them against the latest data to see if those hypotheses still hold true, if they're still supported by what we now see. So that's an important point. Do you know what this object is? It's a comet. Yeah, exactly. Comets are part of our solar system. At least most of them are. There's some that aren't. We'll get to that. They travel in very radical elliptical orbits. So it's a long journey. They come to the sun. They slow down as they leave, and they come close to the sun again. But they're anchored in our solar system gravitationally. And Comet Hale-Bopp has a period, which means how long it takes it to make one complete journey. Its period is 2,533 years. And it showed up in 1995. So in another 2,500 years, we should expect to see it come back again. Scientists think that this was a pretty pristine comet. It may have only been around the sun one time before it came in 1995. I was here photographing that comet right here on these grounds. That was a lot of fun. And those were back in the old film days. Yeah, I'm old. And yeah, I had 400 ASA film and a Minolta 50 millimeter lens, and took some pictures of that. It's about 25 miles across at the nucleus. Comets have two tails. They have an ion tail, which is gas. And you can always tell where the sun is because the ion tail is very light particles and they're affected by solar winds. So the solar wind, you just have to follow this and say the sun's right there when this picture was taken. Now dust tail has heavier particles, and so it's more affected by the motion. And so you can look at the dust tail and you can see that the comet's moving in this direction because the dust tail always lags behind. So you could tell the direction, and you can even tell relative speed because of the gap there. But yeah, so you can tell a lot just by looking at the comet's tail. And Hale-Bopp was great because it was a classic. You really got a classic ion and dust tail. You don't always get that. Sometimes you just get one tail and they're both together. And sometimes you can hardly see a dust tail. So those are a lot of fun. But you know what's so scary about that? That doesn't look scary. And it's not. I just put it there because it's a pretty picture. But there's another comet that came 2 years before, Comet Schumacher-Levy. And it was discovered in March of 1993. And it doesn't have an orbit anymore because it doesn't exist anymore. It was first detected on a photograph taken in March of 93 with a telescope on Palomar Mountain over in California. And the magnitude of the comet was reported 14, which is pretty dim. The higher the number, the dimmer the object. And our eyes can see to about 6.3 magnitude. So this was even beyond a binocular view. And when they were studying the orbit, they realized that it had come close enough to Jupiter about a year ago, a year before that, in July of 92. And the tidal forces of Jupiter, that means the effect of gravity on one side of the comet versus the other side, the tidal force. It's the same force that the moon uses to produce tides on our planet. It tore the comet apart. It just ripped the thing apart. And so it broke apart in July of 92 into 21 fragments, and they slammed into Jupiter over a period of several days, centered around July 19th, 94. I remember that was really exciting for us. Astronomers to see that. So if we saw that coming towards the Earth, that would definitely be scary. It looks scary, and it is scary. And even the marks it left on Jupiter are scary. You know, as astronomers, it hit the other side of Jupiter, so astronomers had to wait for Jupiter to rotate into position, and then we saw these things. And just to give you an idea of the scale, some of these plumes are bigger than Earth. I mean, that's a major damage. Now, of course, this isn't an iron-based planet. It's a gas-based planet, so it's a little easier to punch holes in it. But still, a hole the size of the Earth is a hole the size of the Earth. So the fragment hit at about 36 miles per second and sending plumes thousands of kilometers high. Left hot bubbles of gas in the atmosphere and these great dark scars that you see that lasted for months after the collision. The largest fragment was estimated at 2 kilometers. So think of that. The largest fragment was 2 kilometers, 1.6 miles about, and it made a hole the size of the Earth. That's pretty powerful. It was the first time humans ever saw objects outside of Earth, but in the solar system, collide. So that was a historic moment. So we're going to switch gears a little. We're still in the solar system. Only 2 man-made objects have ever crossed the boundary between our solar system and interstellar space. That means actually left the solar system. Anyone know what those objects are? Voyager 1 and 2, launched in the 70s on technology that is a tiny fraction of what we have in our pockets on cell phones, and they're still going. Unbelievable. But we only know of 3 objects that have made the reverse trick, that have come from interstellar space and have come here, right? So I talked about the elliptical orbit. If something's coming from interstellar space, it's a hyperbolic orbit. A parabolic orbit is the border between those two. It's just enough angle to get it to leave the solar system. Parabolic comes from way out of the solar system, goes around the sun, and then shoots out the other side. So these 3 objects we're talking about now were all on parabolic orbits. They were coming from outside the solar system. So the first one, which is Oumuamua, named on Hawaii because it was discovered on Hawaii, Mount Haleakala. It's a really cool observatory. So I'm lucky enough to have been there a couple of times. It's on Maui, the island of Maui. So they discovered this on November of 2017, so not too long ago. The Pan-STARRS telescope is the name of the scope that discovered it. And the name means scout, which is kind of a scary name for it also. It comes from outside of our solar system, and it's named Scout. And actually, in the beginning, it was such a weird object that one of the hypotheses was that it was an alien craft. It's not. But that was certainly one. I mean, if you're going to find intelligent life, you have to keep that option in the mix when you're making your hypotheses until you prove that it wasn't. And I had talked about this at length in other talks. But it was just this, the object was described as cigar-shaped and reddish in color. And it was a lot brighter than we would expect. It's about 167 meters wide, and just about a kilometer long. So not too big an object. It was 10 times longer than it was wide, and it was a ratio greater than anything we had observed in any comet or asteroid. It really was a strange object, and it even seemed to accelerate a bit. And scientists explained that as that there were probably some frozen ice or something that as it came closer to the sun, it melted and it gave the gas just enough push to make a slight increase in the velocity over what we would expect. And I'm just amazed that we have instruments that can measure that small a change. The higher the technology, the more information we have, and the tighter our hypotheses become. So the second one that visited us followed in 2019. It's called 2I Borisov. And it was first seemed like a typical comet. It made its way around the sun in December of that year. And a pair of papers came out in 2021 using some data that came from the Very Large Telescope in Chile that indicated that the comet is more polarized than anything we've seen. Well, not American politics, but it's pretty polarized. Sorry, I had to go there. So we've studied the solar system, and it just means that this is what seemed to be a very special object. And by the size of the particles, one paper thought again that this was another very pristine comet, much like Hale-Bopp, the first one that we looked at. So the importance of this visitor is the similarities with Hale-Bopp, because remember, Hale-Bopp came from within our solar system, and this came from without our solar system. And so they're thinking it might be a similar type of solar system that this came from. Now, of course, the second paper that came out said the exact opposite. So the jury's still out on that object. They have a lot more data to pour through, and they're still looking at it. Doesn't look too impressive, but that's our third interstellar visitor. And it just zoomed by Mars a week ago, a little over a week ago. It's called Comet 3I Atlas. And tracking its hyperbolic orbit clearly originates it from outside the solar system, just like the other two. The closest approach to Earth will be about 170 million miles. And then we're 93 million miles from the sun. So that's pretty far off. The comet will reach its closest point to the sun on October 30th. We can't observe it now because it's too close to the sun to observe, but it'll come around and we'll be able to pick it up again in December. We'll be able to, amateurs and professionals alike. And by the way, comets are usually named after their discoverer, and then they're given some other names just to make it look real scientific. But third is the third interstellar. I is interstellar. And ATLAS stands for Asteroid Terrestrial Impact Last Alert System. It's a survey telescope in Chile looking for unusual objects that might hit the Earth or at least come and we don't know about it. This one image was captured by the Hubble Space Telescope on July 21st, 2025, when it was 277 million miles from Earth. I had to throw this one, and this really doesn't look like much, but this is, to me, this is an amazingly cool. This is the same comet, Comet 3I Atlas, but it was taken from the European Space Agency's Mars orbiter, ExoMars. So this was taken from a spacecraft that is 200 miles above Mars, mapping out Mars. And so the equipment is made to take pictures of something 10,000 to 100,000 times brighter than this comet. But they said, hey, why don't we just point the camera there and see if we pick something up? So this was taken while the comet was 18.6 million miles from Mars, taken from 200 miles above Mars. Just unbelievable technology we have these days. I'm so glad those guys decided to take a chance and just point it, because it costs money to do anything up there. It's not free. It's not like you and me taking a pair of binoculars. So I included these three visitors just because they get so much hype. You know, sometimes scientists will say, well, maybe it's something alien. We don't know. It's so strange. And, you know, what happens on the internet? It lights up. You got YouTube videos. You got everybody. You got cults. Everybody's got their say. So, and people try to make you scared of this stuff. It's, you know, whatever gets clicks. Great clickbait when someone says, if you can quote a scientist saying, well, one of the possibilities is it could be alien technology. Boing, boing, boing. Money, money, money. So this is an Arecibo radio movie of asteroid 1950 DA. And I found this on Wikipedia. I thought it was pretty cool. Arecibo was a radar telescope, radio telescope, that we lost in 2020. It just collapsed in itself. It was an old scope, but it took some really great stuff. So this is a 48 minutes of observations, and it shows 37% of the rotation of this asteroid. That was taken a while ago, March of 2001. This asteroid was discovered way back in 1950, and then we hadn't seen it for 50 years, and then we see it now. It's about 2/3 of a mile across, and was estimated to have a 1 in 360 chance of hitting us on March 16th, 2880. So 800 years out, they predicted this at a 1 in 300 chance. And March 16th, that would ruin St. Paddy's Day that year for sure. But the European Space Agency, they've got a near-Earth object coordination center, and they changed that estimate with more data to 1 in 1,350. It's currently about 1 in 8,000, then it jumped to 1 in 50,000. So it's getting smaller and smaller. And you know, I certainly can't fault them for inaccuracy, projecting 800 years out into the future. I couldn't even tell you what I'm having for dinner tomorrow. But it's pretty cool. And not to be outdone, NASA's JPL now has their own Center for Near-Earth Object Study. And NASA has a Sentry system. And who knows what China and Russia have. But everybody's looking out there to see if they can pick up stuff that's coming in. And I'm sure military applications aren't far behind. Usually they lead the way. So here's 1950 next to some other big boys. Bennu, the asteroid in the middle, is tagged the most likely to hit Earth within the next 300 years, according to NASA. And that chance is 1 in 1,750. So not too bad. So to help you sleep tonight, there is no imminent threat from large asteroids. And it's kind of fun to look up this data. But if you're online and you see data from something called like the Comet Cult or something, I would ignore that data and keep looking. Keep looking. There's some, NASA's a great source. European Space Agency, they're all great sources. And all this stuff that I'm using here, except for the pictures I take myself, which I don't think are any here, they're all available. You know, you're a taxpayer. You paid NASA already to take these pictures, and they're up there. Hubble has a site, James Webb has a site, NASA, JPL, they all have sites. And you just go up there and you can really, it's stranger than science fiction. So spend some time learning something that's true, that's out there. So of course, mini asteroids, known as meteoroids, they regularly impact the Earth. Most of them just burn up. They might burn up in a fireball or a halide if they're big enough, and once in a while they do hit the Earth, and then we call them meteorites or insurance claims, one or the other. But this was an interesting. This is a picture of the Chelyabinsk airburst over that Russian city on February 15th, 2013. Not too far away, not too far ago. And it's funny, in that city, dashboard cameras, maybe they're real bad drivers, but dashboard cameras were really popular. And so a ton of pictures of this were posted on YouTube and the internet as soon as it happened, because all these dash cameras produced some amazing footage of this. The asteroid was about 66 feet in diameter. And as you can see, it came down at a shallow angle, which is good because that means it burns up more than coming straight down. It had a lot more atmosphere to go through at a speed of 42,000 miles per hour. It exploded less than 19 miles above the ground with a force of about 500 kilotons of TNT, 30 times the explosion of Hiroshima. So just an amazing explosion. Fortunately, most of the energy was absorbed by the atmosphere, but still it damaged over 7,000 buildings, and about 1,500 people were injured. Now, this is weird. The main cause of the injury was that people were in their apartments and in their homes, and they saw this amazing, the flash of light that came from this explosion was amazing. So they saw this amazing flash of light, and they all ran to their windows to take a look at what they were looking at. And the shock wave was much slower than the speed of light, and so it came and it hit the windows and broke the windows while people were looking to see what was going on. And that was most of the injuries. And I'm sure that was probably most of the damage to the buildings that's reported. All the windows fell out from the shock wave. But there were no fatalities as far as I know. I didn't see anything about fatalities. So I think it was just cuts and abrasions from broken glass. So let's move away from incoming projectiles and see some beautiful objects with frightful power and that are far enough away that we don't have to go, oh no, I hope that doesn't come over New Jersey. So just to take a look at what happens to a star. This top is what's going to happen to our sun, and any star that's up to about 8 times the size of our sun. What happens is you get a nebula of clouds, and they finally get gravity, and they condense on themselves until it gets so hot that nuclear fusion hits, and they finally hit hydrostatic equilibrium when the fusion pushing out and the gravity pulling in reach equilibrium. That's where the star stays most of the time. For our sun, that would be about 10 billion years, and we're about halfway through that. So there's our sun just sitting there. When it runs out of hydrogen and hits helium, it turns into a red giant, something like Betelgeuse. You've probably heard about Betelgeuse. And it becomes a big red giant star for a while. And at this point, we'll be inside the sun. Right, that'll come all the way out, probably up to Mars, certainly past Earth when it swells. And then it finally collapses. Half of the mass of the sun will become this gaseous envelope that'll last 20 to 70,000 years, and the other half becomes a white dwarf, which is a star, a dead star. It's no longer burning. It's no longer fusing elements, and it's the size of the Earth. So half of the mass of the sun in an area the size of the Earth. So you're basically talking a metric ton for every cubic centimeter of matter. Very, very hard to lift, obviously, and you couldn't get close enough to it anyway. So that's sometimes stars under 8 masses are called dwarf stars because they leave behind a white dwarf. And so we're going to take a look at these planetary nebulas. They were called planetary nebulas before we knew what they were. In the 17 and 1800s, they had these little scopes, and all they saw was a little fuzzy object that looked like a fuzzy planet. They knew it wasn't a planet, so they called it a planetary nebula. So this is a cool one. This is a composite. This is M57, the Ring Nebula, And if you come here often enough in the summer and sometime in early fall, you could see this through one of our telescopes. But you'll only see a little cloudy looking smoke ring that's very, very small. You don't, this is visible light from Hubble. This is all infrared light that you couldn't see through a telescope anyway. And astronomers and imagers add false color to anything that's infrared so we can see it. But obviously, if they put it in the infrared spectrum, you couldn't even see a picture of it. But this is the visible. There's the magnitude 15th magnitude star left behind the white dwarf. And this is about 1,630 light years in Lyra. It's called a face-on ring. It's very ordinary, but I wanted to show you what a very ordinary one looks like so you could appreciate what some of these other ones look like. So it's not scary, it's just beautiful. But so that's what a regular planetary, your textbook style is. Now there's all kinds of different ones as well. I like this one. This is an image from the Spitzer Space Telescope, and this is infrared, so it's been mapped into visible light so we can take a look at it. It's from the well-studied Helix Nebula, which is also beautiful in visible light. NGC 7293. It's a popular target for amateur astrophotographers like the ones that hang out here. Some refer to it as the God's Eye Nebula. It is kind of creepy to see that looking back at you if you're looking through a scope. Reminds me of like one of those Warner Brother cartoons from way back when. It's one of the closest to the Earth, and it was discovered back in 1824. And I think it at least qualifies for spooky. Not too harmful, but spooky. Here's another planetary nebula. This one's known as the Little Ghost Nebula because it's very round and very faint. I think it looks like another eye. Yeah. And it was discovered in the 18th century. So, you know, it's amazing. Obviously, they didn't see that, but it was discovered by William Herschel, who's a very famous astronomer, and he used the telescope to explore the constellation Ophiuchus. So remember, as I said, a lot of these objects just didn't look anything like this when they were named. The nebula's main ring structure here is about 1 light year across, and the glow is from ionized oxygen, hydrogen, and nitrogen. So it takes the light from here a year to get over here. That's a pretty big object. This is one of my favorites. It looks nothing like a planetary nebula. It's the Butterfly Nebula. It is just gorgeous and deadly. It's found in Scorpius, so we can see that up in the northern hemisphere. It's known as a bipolar nebula, as you can see. It's not because it takes lithium, but we see 2 poles sticking out there, and we have a tight dust collar right here that's responsible for that bipolar. It's about 4,000 light years from us, and one of the most complex structures of any planetary nebula. Just amazing. And although it looks beautiful, it's got some amazing power behind it that qualifies it as scary. First of all, the spectrum of the center star is one of the hottest stars known. And remember, this is a dead star. The surface of the temperature of this star is estimated at 450,000 degrees Fahrenheit. Compare that to our sun at just under 10,000 degrees. So that's about 45 times hotter than our sun, and it's a dead star. The original star was estimated to be about 5 times the mass of our sun, so they call it 5 solar masses. And now it's only about 64% of the mass of the sun. So that fits right in with the model of planetary nebulas. The central star can't be seen because of that donut-shaped ring of dust, which appears as a dark band pinching the nebula right in the middle. And you can see equatorial belt of dust and gas, which, as I said, astronomers feel is causing the bipolar shape. But however, this is a weird one. Scientists recently discovered that this and other bipolar nebulas have discovered that these nebulas are in surprising alignment with each other. In other words, a lot of them are pointing in the same direction. So that's kind of spooky. Except they think it has to do with the galactic plane of the Milky Way and the magnetic field in our galaxy. That's the current theory. We'll send up another spaceship and see what that says. Um, but to hype it, you could say, random force or unseen force. Uh, the outflows. The outflows of these beautiful wings of the butterfly are really roiling cauldrons of gas, more than 36,000 degrees Fahrenheit, really hot. Uh, Fahrenheit and racing across the space at 600,000 miles an hour, fast enough to get from Earth to the moon in 24 minutes. So this is expanding. This image was taken in 2009 from Hubble. So since this image was taken, it's been expanding at 600,000 miles an hour. You just can't even think in that kind of a scale. And of course, it's how many light years did I say that was? 4,000 light years. That was 4,000 years ago. So it's even bigger than that. This is the exact same image, but a different a different coloring. So that was the same data as the other picture, just to show you how different the image can look when it has a different person mapping out the data. This is another where am I here? This is another image. It's a different image of the Butterfly Nebula. It was taken by the Hubble in ultraviolet rather than infrared and visual. Let's see, where am I? All right, so we looked at remnants from a star like ours. Let's look at what happens to more massive stars, something over 8 solar masses. They also spend most of their time in hydrostatic equilibrium, burning through, but they keep burning on till they get to iron. Iron is the first element that requires more energy to fuse than it gives off. And what happens as soon as iron gets into the core, the star collapses in on itself, and we have a massive supernova explosion. And then depending on the mass of the original star, it'll either become a neutron star, or if it's more than 80 times the size of the sun, chances are it will become a black hole. Now these explosions are so bright, they're visible at immense distances. If a nearby star were to undergo a supernova explosion, it would be so bright that it would be visible during the daytime. As a matter of fact, back in 1054, the supernova that created the neutron star in the Crab Nebula, which is a winter object, was recorded by Chinese and Japanese astronomers, and so we have those records, and we know that they were able to see it in the daytime for about a week after it went. It was just a star that appeared. They had no idea what they were looking at, and then 1,000 years later, we got an idea what they were looking at. So this is a ground-based telescope image of a supernova about 2 weeks after the explosion. And it's hard to capture just how bright this explosion is, but that supernova explosion outshines the rest of the entire galaxy. It's amazing. And this is the Tarantula Nebula in the Large Magellanic Cloud, which I got a chance to see from New Zealand. We can't see it from here, but you could see the cloud naked eye. And this is amazing. I actually got to do some photography of this Tarantula Nebula last March. Very cool. But this supernova took place in the late 80s, somewhere in the late 80s. This is just an artist rendition. It's not an image of a shock wave from a supernova. What it could look like a few seconds after it went. More specifically, a Type 2 or core collapse supernova. That's what we're talking about. The brightness in that explosion is equivalent to about 10 billion suns. And the energy released is 10 to the 44th joules, which is equal to all of the energy released by our sun over its 10 billion year life, released in just a split-second explosion. I mean, it's just mind-boggling. So I guess this counts as looks scary and is scary. Would not want to be anywhere near that explosion. And these explosions leave super dense stars known as neutron stars. They're even denser than a white dwarf. You get a neutron star could have a mass greater than our sun in about a 12-mile area, like Manhattan, having the density of our sun. And not only that, but spinning around. It's I don't know how you even start to imagine it. So it's 1 trillion times more dense than our sun is a neutron star. This is an illustration of a type of neutron star that has an accretion pulsar. That's an accretion pulsar. Accretion means that it's gobbling up something else. And there are neutron stars that do that. Most black holes do that too. Matter of fact, that's how we took an image of our first black hole. It wasn't because you could photograph the black hole, which doesn't allow any light, but it had an accretion disk. And so we were able to photograph it, and there was a big silhouette in the middle, which was the black hole. This is a neutron star. It's smaller than black holes are all different sizes. It's less dense than a black hole. It's still giving off radiation. These are bipolar as it eats. It's giving off these relativistic rays, gamma rays are just shooting out. And as this thing spins around, the one in the Crab Nebula spins around at 30 times per second. And so it's almost like a lighthouse. You see it clicking 30 times a second. This one is a lot faster. How much was it? I'll get to it. But this one is in Hercules. It's from 2022. We discovered it, and the observations of this system is really changing the way that we think about neutron stars. We're learning a lot of stuff from them, and again, incredibly dense. I wanted to see what the okay. This one is I believe it goes around over 100 times a minute. There's one other accretion disk that's really very wild, and that's the Black Widow pulsar. Even has a Halloween type name. It's also known to scientists as pulsar PSR B1957 plus 20. It's a dangerous partner to have. It weighs as much as 2 suns, but it's only as wide as Washington, D.C. And it's getting bigger and bigger by feeding on this poor little brown dwarf star. A brown dwarf star is a star that is lightweight and it's as cool as a star can get. If it got any cooler, it would be a Jupiter. So it's bigger than Jupiter, just enough so we have some fusion, but it's very, very cool. And it's being taken advantage of by this widow. The 2 stars orbit around each other every 94 minutes in a deadly close dance. The actual photo of this is not exciting. This is an artist's rendition. The real photo is like a very ho-hum thing because it's so far off. But the pulsar is seen in the background, right? So that's the pulsar. You could tell by the jets, the relativistic jets, and and we're seeing it. This is represents a cloud of gas that's being stripped off of this brown dwarf. So, and they're roughly 2 million kilometers apart, which is 1.6 million miles compared to 93 million miles for the Earth, and even Mercury's 46 million miles from the Sun. So this is like in your face as it's eating you up. And that pulsar spins at 600 times per second, and it's gaining velocity in its speed because as it eats up its companion. That's known as a millisecond pulsar. So finally, if a star is more than 80 solar masses, plus or minus, the supernova explosion leaves us a black hole with a very voracious appetite, of course. These are some of them are so massive, well, all of them are so massive that they bend the very fabric of space-time, which is amazing. We saw there's accreting pulsars. Most of the black holes accrete matter. They're eating something up. They're glowing. That's a lot more common. They're always eating. And sometimes we find a black hole that's so big it's mind-blowing. There are black holes in the center of most galaxies. There's one in the center of Milky Way. If you look towards Sagittarius, you're looking towards the center of our galaxy. But this is amazingly large. This is just an artist trying to show us how big this supermassive black hole is in relation to our solar system. That's our solar system to scale. Remember, neutron stars were only 10 to 20 miles across, and we're not as dense as black holes. So this thing is like a monster. It's bending light to such a degree. A lot of them bend light so that they form gravitational lenses. So you could see a galaxy right behind this black hole because the light is bent, and the light from the galaxy back here actually comes off on the side. And I'll show you some pictures of that. Einstein predicted it, and I think it took us till the 70s to prove him right. But now we have all kinds of pictures of gravitational lenses, and we're getting a lot of information out of that. Let's see how we're doing on time. This black hole is known as an OVV, or optically violent variable. It's a hyperluminous black hole. It belongs to the most energetic subclass of active galactic nucleus. So it's at the middle, it's in the center of a galaxy. The luminosity comes from rapid accretion of matter. It's eating a lot, and it's eating it fast, and you don't want to fly too close to that baby. It's one of the most luminous objects in the universe in terms of absolute magnitude. And again, this is an artist rendition. When it looks this good, you know it's an artist rendition. I just find it more interesting to look at that than a little tiny blip from Hubble. So to give you an idea of the energy that this has, if this were a quasar, this quasar was 280 light years from Earth. It would give us as much energy per square meter as the sun does at 100 million miles at 280 light years. That's where the energy from this to the Earth is equalized with the sun. Just amazing. It's 300 trillion times as luminous as our sun. It's over 25,000 times as luminous as the 100 to 400 billion stars in our galaxy. It outshines that by a factor of hundreds. Luckily, it's 12.1 billion miles away, so we are not going to be getting a suntan off that baby. Let's switch gears again. Here's an object that we can often see in the late summer and fall, the Andromeda Galaxy. And I just showed you, this looks like a baseball diamond right here, Pegasus, the great square Pegasus. And if you look at third base, you can find it. I look at these two stars, and I look at these two stars, and then go the same amount. And on a good night, even here, it's naked eye. You could just barely see it. You use averted vision, which means you don't look right at the object, you look to the side of it. And the cones in your eyes, which are more sensitive to light, all of a sudden, it's amazing. All of a sudden, it comes into view and you're not looking right at it. You can do that with binoculars as well. So, nothing to induce great fear, is there? This is just to show us the scale. The Andromeda Galaxy is very, very, it's a bright object, but it's spread over so much that it's still hard to see. You usually just see the core, and you need to do a photographic exposure to get the full extent. But this is how it stacks up to the size of our moon. That's drawn to scale. So that's a pretty big object. It's the closest galaxy to us. Even more realistically, if the Andromeda Galaxy were as bright as the moon over its entirety, this is what a sunset would look like. So it's quite large. Of course, you see nothing like that, but it's drawn to scale. So what? Well, this gorgeous example of a spiral galaxy is moving towards us at the speed of 190 miles per second. Uh-oh. Most galaxies and objects move away. The universe is expanding, and most things are moving away. And the farther away something is, the faster it goes. But there's some local objects that are moving towards us. So instead of a red shift in the light, we see a blue shift. And this is one of those objects that's moving towards us. And it's predicted. Now there's been some descent in the last year with new data from James Webb. But when the Hubble took measurements, it was predicted that these two galaxies, the Milky Way and Andromeda, would collide somewhere around 4 to 5 billion years from now. No worries, we're going to be inside that sun anyway in the red giant. So it's not a factor, even for someone who happens to live 4 billion years. But it wasn't until 2012 that we had the data from Hubble that made us think they were going to collide. And now this year, it's not the majority opinion, but there's enough dissension there now that they've got to step back. So maybe it's not as scary as I thought it would be, but there could very well be a collision. And these are just some computer simulations of what that collision might look like. You know, there's an awful lot of room between stars in our galaxy, and so there will be new stars born. But a lot of the galaxy will just pass through each other. The closest star to us is 4 light years away. Now there are some globular clusters that have 100,000 stars packed in a little globe, but there's a lot of space. Space is mostly empty. This is a real galactic collision. Merging galaxies NGC 4568 and 4567. Astronomers at the Gemini North Telescope in Hawaii captured this stunning image of these two galaxies colliding. This is just a relative size of the Milky Way, about 105,000 light years. Andromeda is about 200,000. Triangulum is another nearby galaxy that might join the party if they collide, but we've got to look at the data again. Well, if you've got a merge, might as well make it a cool merger. And this guy's looking pretty cool. The piercing eyes of this creepy space figure are actually two distant galaxies in the middle of a head-on collision. And they're surrounded by a mishmash of stars from the respective galaxies. These are all new stars that are being formed all around it, and it makes a very cool looking face. It's about 704 million light years away from us in the constellation Microscopian. And yet another collision. The Devil's Mask is what it's called. Scary. KTS 59. It's a galactic triplet. And it was discovered in 1836. Those were real astronomers back there. You can discover stuff like that. I'm just going to get through some of this a little quicker. This is the Ghost Nebula. It's a reflection nebula in Cephus. Again, it's about 1,500 light years away from us, and it's a gas cloud that looks a little like a ghost. There's a better picture of the same nebula. I like it a little better. About 2 light years across here. So it's a pretty big object. It almost looks like a goblin or a bat, but Ghost Nebula it is. And there was my opening to Ghost Nebula and little goblins. This is a wider crop around it. This is a section of the Carina Nebula known as Mystic Mountain. Kind of looks a little Halloweeny. I like it. It was taken from the Hubble. 3 light years from here to here. So that's pretty big. That's like one of the towers in the Pillars of Creation in the Eagle Nebula. The Rosette Skull Nebula. Yeah, it is. It's a Skull Nebula. That's the name. It's an emission nebula with a radius of about 65 light years. So that's a big skull floating out there. Here's the Cosmic Bat. This is a tough one because it's what we call a dark nebula, and it's really hard to photograph a dark nebula. But I think this picture is just amazing. It really does look like a bat, and it's got this bright reflection nebula behind it, so it's kind of like getting a little backlit from it. Very cool. Here's another bat nebula. It's a different one. Totally different. Yeah, that's part of the Eastern Veil Nebula, which is the Veil Nebula is a supernova remnant that is so big you just can't. You have to do a mosaic in a telescope, or even a camera. It's huge. Yeah. Okay. So again, it's what a supernova left behind when it exploded. I'll skip that one and go right to the last eye. NGC 4632 is a spiral galaxy. That's a galaxy at a distance of about 100 million light years from us in the constellation Virgo. And it was discovered in 1784 by good old William Herschel again. So recently, astronomers discovered a polar ring around this through observations at radio bands, and so this is a depiction of what was discovered on radio frequency, not visual. And we have looked at some of our scary objects. I hope you can sleep tonight. I enjoyed it. Thank you.
All right. Thank you, Walt, for another great presentation. Sorry, hon. All right. So we are going to be doing a question and answer session. How that works is for people here, you're going to raise your hand and I'm going to hand you the microphone. Because chances are, if you had a question, someone else might have the same question but not be brave enough to voice it. And we like our online people to be able to hear the question. Online people, you have it easy. You just get to type, and we do have a number of online questions, so that's always fun.
Okay.
Just as a reminder, if anyone needs to use the restroom, that is the porta potty outside. It is blue. It is illuminated by a red light. When you were on the way into this indoor lecture area, you did pass through the little museum area and gift shop, which I will be manning after question and answer session because it is against the laws of physics I be in 2 places at once. And quite frankly, I've also been told since last week that one of me is more than enough. So that being said, we're going to get going on the question and answer session and open it up with our first online one, which is, would life on Earth survive being hit by an object like what made the Earth-sized holes in Jupiter?
That's an interesting question. It would certainly change Earth, and I'm saying most life probably would not survive that. That's probably the type of impact that took the dinosaurs out. I think the cockroaches would still survive, so there's hope for them. But yeah, it's tough. And also if it hit, because remember it's 2 kilometers, so if it explodes above us, you got a better chance. If it goes into the ocean, it might cause some major tsunamis, but you got a better chance there. So it really depends on where it hits, when it hits.
Cool. Any questions out here? Only the crickets from outside because I opened the door. It was getting quite warm in here.
Yeah, for sure.
All right. So our next online question: Are are the objects from outside our solar system from other systems in our galaxy, or is there a possibility that they are from other galaxies like Andromeda?
It could be both. Hamuamua was traced back. It came very close to a star. I think it was 4 or 6 light years away from us. They actually traced that trajectory and they came up with some possibilities of where it could come from. Obviously, because there are so many solar systems within our galaxy, that would be our first guess, rather than have something travel not only interstellar but between galaxies. That's a much harder job.
We think the hour jog to Grandma's house over the holidays is a long trek, which
But
they have to move galaxies.
there are objects that go between galaxies. There's stars that are rogue stars that just travel between galaxies and stuff. So it's not impossible. It's just less probable.
All right. Like I said, if at any point you guys have a question, do feel free to raise your hand. Let's see. Are the odds? You were going over odds. I think this was during the meteorite. Are the odds better or worse than winning the Powerball lottery that the Earth get?
They are better. As
So
better.
we're more likely to get hit by a meteorite than winning the lottery.
Absolutely.
Neat.
I mean, those I didn't mention any odds that was more than 1 in a million, right? And the odds for Powerball are much higher than that.
Yeah,
So there you go.
I'm kind of just never tell me the odds. So
I will. So you showed like the photo of like the meteorite that like exploded over like Russia but didn't actually impact. Aren't we supposed to like detect that before it happens?
On a good day, yeah.
Yeah. Okay.
yep. So fun thing about meteorites is most of them are like the size of a grain of sand that you're seeing. So it's a matter of scale.
This was a big one.
Those were big, but it's still when they're moving fast and they're not like earth shattering, like here's the city of Manhattan hurtling over you. It's a little harder to detect.
It is, and my guess is they detected it, but with not any time to do anything about it. Very
Oh,
quickly.
look, something's coming into our airspace. Oh, look, it crashed. Is probably how it looked. All right, so our next online question is actually not a question. One of our online viewers said they're fairly certain the prevalence of dashboard cams over in like Russia and whatnot has more to do with people trying to run insurance scams than being bad drivers.
Whoa, that's a good point. Yeah, I don't have that devious a mind, but yeah, I can see how that
Yeah,
that would work.
When enough people try and brake check you, you start going, "Ha ha! I have proof that you are
Time
being."
to put a camera. Yeah. Okay.
All right. So the question after that: does the spinning help you become more dense, or is that something that allows you to expand?
No, it increases the angular momentum increases as it gobbles up more stuff. So what helps you expand is gobbling up your neighbors. And I, one thing about giving a talk like this, you cover like 30 different types of objects that people devote their whole lives studying one of them, and then field any questions. So I'm no expert in orbital mechanics or physics, hated math, but yeah. So I don't know all of the mechanics behind that.
We had another question over here.
So, but you're probably an expert on your own life, and I was wondering, of all these amazing places you've been, what was your favorite?
Oh, for astronomy, New Zealand was a jaw dropper. It was. I had been in Rwanda. I was working on we were helping. It was a mission trip helping a coffee plantation, and it was supposed to be just outside the rainy season. Well, it wasn't. So I got a couple of peeks up into the sky. The thing about the South is you see stuff that you just don't see here. And so when I was in New Zealand, and I was at places that were like dark sites, where the Milky Way was so bright it slapped you upside the head, and it was just so. And there were kiwi birds are nocturnal, so there was one airport where airstrip that I was observing, and there's these little kiwi birds about that high are like running by and stuff. It was really cool. But
Wait,
I got some.
kiwis are.
Yeah, kiwi birds are like
I thought
not
it
the
was
fruit.
like the size of a Nerf football.
No, they're
Like,
they're like
I'm here expecting a kiwi bird to be like this, where I could pick it up and just.
no.
Okay.
They're amazing. So it was just amazing to see the Magellanic Clouds and Carina, all the stuff that I'd read about, Alpha Centauri, where the Lost in Space people went. So that was my favorite, just because it was so unique, and I was able to go to really dark skies. There's some dark sky sites here too that are a lot of fun, but that one takes the cake. I never thought I'd get there, and I had bought this. I tell this in my smart telescope talk. I bought this little smart telescope that could fit in a bag, and before it was even delivered, my son called me up and said he'd like to take me to New Zealand for a trip, and I was there. Now I'm just like, how can I get back there, and how can I get my big scope, my real scope, there instead of just a little thing.
What if you, instead of trying to haul your equipment, find out if there's like an astronomy club doing a rental thing where you can just then pack your like laptop and camera and whatnot.
I'm actually that's funny. I was talking to my son. I'm thinking of posting on a astrophotographer board, calling all New Zealanders, give me some advice here, and see what they come up with.
Which is also why we tend to tell people join your local astronomy club, or if you're going to visit a place for and think you're going to do astronomy, look up the local club in the area. They're going to have all those tips and tricks. For example, a lot of people might come from places like New York City, and the tips and tricks I know for out here in Warren County, New Jersey, aren't exactly the most helpful for people in a very light polluted city. And I'm also obviously not going to know those hidden gems of, if you go to this spot around this time, you'll get a great view of this thing. And I don't know that stuff, but they will.
And that's important. Where's the best western view? Where's the best eastern view for planets that are going to be just above the horizon? It's good stuff. But that great segue into the local club, I like that.
It's almost like I've been doing this for a couple years.
Great talk. Thanks for that. I have a question. So we currently know that a snapshot of our universe, like 500 years back. How do they do it actually? Like, like the universe is here, you get a snapshot of it moving far away, or like which direction do they go and look, and like how do they piece all of them together to
Now,
find
are we talking about the galaxy or the universe?
the universe? Like we
Okay.
track all the way back.
So all the way
guess.
back 13.8 billion years. They have to do all sky surveys. And there's a telescope, I forget the name of it. It was just installed in Hawaii that is doing an all sky survey now. And you have to take mosaics of the entire sky, and then put them together. It's going to be amazing. I hope that they build a room or something so you can like step in and just have the entire universe surrounding you. But the photos that are coming out of it are amazing. The resolution on that camera, and it's going to take a couple of years to get that done.
All right, we got another question out here.
How do they breathe in space?
With an
How-
oxygen tank. That's the only way you can breathe in space. Put a
You-
spacesuit.
Then you ain't gonna be breathing very long.
Talk about scary. There you go.
This is why NASA has all those redundant systems that seem redundant until something happens, and then you're like, haha, not dead yet. All right, so our next online question is, if we, I guess people in general, got close to a black hole, would we be able to see it, or if we can't see it, would we be able to perceive it in other ways?
We could perceive it by its silhouette. And then we can also perceive it by the fact that you would be stretched thin like a piece of spaghetti for miles long.
I'm assuming they want to
and-
sit far
and that
enough
would definitely-
backward. They're not going to become the spaghetti and be like, ah, yes, over there, that's the black hole. You could tell it's a black hole by the way it is.
Yeah, only because. All right. We'll have that discussion in the car on the way home, okay? Thank you very much.
For,
No.
for those online, we have a young gentleman who just suggested human spaghetti sounds delicious.
But you'll be able to see the black hole from what it's around. You'll either see, as I said, the accretion disk. Also, because they're gravitational lenses, you will see views of warped galaxies that look really stretched out all around it, and you'll actually see around it that the very fabric of space-time is warped, and you can see that in pictures from Hubble and James Webb. You could see how it's warped around them. It's amazing.
All right, online people, if you have any last-minute questions, I do encourage you to get the in. I do like to give them a little bit of warning because by the time they get that message, we're already 2 minutes into the future. Stream delay and time travel problems. Any other questions out here? Bueller? I got at least a couple chuckles, so someone at least gets the reference. While we're giving it a couple minutes, I do want to once again thank you, Walt, for another great presentation. Thank you everyone who has joined us here and
thanks for coming.
online. If you ever like, oh man, I should have asked that question, never fear. If you go onto our YouTube channel, we do have these presentations saved. So if you think of a question later, do feel free to either ask it down in those comments or even just send us a message. Like I said, we have our social media, our Facebook, Instagram, Discord server. Excellent places to ask those questions and reach out to us. I'm trying to think if there was anything else, because normally I have a couple things and I am completely drawing a blank. All I have in my head is unfortunately human spaghetti now.
There you go.
Tonight's
Fine
been
image.
fun. Too much caffeine. I don't drink coffee, tea, but yes. All right, so for online people, thank you very much. Remember to hit those follow free actions. We greatly appreciate those because we are a nonprofit and every bit of support helps us, lets us know, A, we're doing a good job and you want to see more, and also helps us get our interest in science and be able to share that with much more people. With that, everyone have a great night. For those of you who are here, like I said, I will be over in the museum and gift shop area. Walt will be here if you have any other questions that you were not brave enough to answer via the mic. With that, have a good night.
Thank you.
Clearer skies than the rain we've been having. And join us on our next two Saturdays. We have our last 2 Saturdays of this year. And then we go to online only programming, and that last Saturday in October, which is the 25th, feel free to come in costume because it is close to Halloween and we like to celebrate spooky season. All right, have a good night.